Hello everyone, and welcome to part 2 of lessons 6.5 and 6.6, Real Roots of Polynomials and the Fundamental Theorem of Algebra. We're going to be focusing on factoring methods for polynomials, and these are ones that hopefully you learned about in Algebra 1. So we're going to look at factoring by a GCF, factoring a trinomial, and some of the special factoring formulas. Okay, in this video, we're going to focus on factoring methods that hopefully you've learned already. So we're always going to start by looking for a GCF first. So you look at all the terms, you look for the greatest common factor, and you factor it out. Once that's done, you can try to factor the trinomial, and you may recall that you have like x squared plus bx plus c. And what you're going to do is you're going to look for two numbers that multiply to c and add to b. Those are going to be the values that go into your binomials when you factor this. And you'll see that when I do some of our examples. Then we have the cubic factoring formulas. These are formulas where you take the cube root of each thing and then you keep them with the sign that was there. You square this x, so square it, write a minus sign, x times y, and then plus the second thing squared. Okay, so you multiply them together here, you square the first, you square the last. Now, one thing to be aware of with these cubing formulas is that there's only ever one minus sign. So if this is a minus sign here, then this has to be a plus. If this is a plus sign, then this has to be a minus. There's only ever one minus sign. Okay, and finally we have the difference of two squares formula, where if you have x squared minus y squared, you take their square roots, you write them down with a minus sign, you copy them again with a plus sign. Technically, the order of the signs does not matter. You can do plus and minus, does not matter. So let's just take a look at some examples of factoring. So the first example I have for you is they've asked us to solve this equation by factoring. We've been given 3x to the 5th plus 18x to the 4th plus 27x cubed equals 0. So to solve this, we need to find the zeros of it. We're going to start out by looking to see if these terms have a GCF. I notice that all the numbers are divisible by 3, and they all have x's in them, and x to the 3rd is the smallest exponent. So my GCF is 3x to the 3rd. So I'm going to factor that out and write my result. I end up getting x to the 2nd plus 6x plus 9 times this. And all I did was I divided each term by this 3x cubed. Now, notice this is a trinomial. In order to factor it, I need two numbers that multiply to positive 9 and add to positive 6. And that would be 3 and 3, both positive. So I'll write those binomials next. Finally, all I need to do is find the zeros for each x. So if I put a 0 in right here, this entire term will turn into a 0, and this multiplication will equal 0, and it will make this true. So 0 for this x. For this x, to make this part 0, I would put in a negative 3, because negative 3 plus 3 is 0. So the 0 for this part is negative 3. And then the same thing would be true of this one. Negative 3 is also a 0 here. And what we would do is we'd write all three of those zeros, but we can say also that negative 3 has multiplicity. Okay, so I wrote down that the zeros are 0, negative 3, and negative 3. It can also be written as 0 and negative 3 with a multiplicity of 2. So let's take a little bit of a closer look at what multiplicity means. Okay, some zeros have what we call multiplicity. So the multiplicity is the number of times that that 0 or root appears. Even multiplicity means that if you look at the graph and it touches the x-axis and does not cross it, I like to think of it as touching and bouncing back, that means that the root there is going to be a root an even number of times. So it could be 2, 4, 6, or 8, or even more than that. Odd multiplicity means that the graph goes through the x-axis at that point, and it can bend there. And the higher the odd number of multiplicity, the sharper the bend. So this means it could have a multiplicity of, well, 1 if it goes straight through and doesn't bend, 3, 5, 7, 9, so it's all the odd numbers. And we can use our factored form to figure that out, like we did in our last example. So let's take a look at another example where we need to use factoring to find the roots or zeros of our equation. Okay, so in letter B, we're given x to the 4th minus 13x squared equals negative 36. The first thing that needs to be done is we need to get everything to one side and make sure it equals 0. And you always want to make sure that your leading term, if it's in standard form, would be positive, because that makes your factoring methods work well. So I'm going to just add 36 on both sides of our equation. Okay, so I got x to the 4th minus 13x squared plus 36 equals 0. Now, notice this has 3 terms. And also notice that this is an x squared right here, and this is x to the 4th. And if I double the exponent here, I will get this exponent. That is the pattern that we see for quadratic factoring, like this trinomial I had right here. So this actually fits the same pattern as the trinomial factoring. So all I need to do is find a number that two numbers that multiply to positive 36 and add to negative 13. And that would be, let's see, 9 and 4 would work if they're both negative. So we'll go with those. Now, the only difference between what I did over here and what I did here is that I'm going to put an x squared here in both of these, because this was x squared in the middle. So here's my x squared minus 9 and my x squared minus 4. Now notice both of these fit the pattern of something squared minus something squared. So these are both a difference of 2 squares. So they can both be factored further. So all I'm going to do, I take the square root and write it down, take the square root of 9 and write it down, and write a minus sign in between. Copy it again with a plus sign, and I'll do that for both of these. Okay, so I had x minus 3 times x plus 3 and x minus 2 times x plus 2. That's the difference of 2 squares factoring for both of those. Now, the zeros. This 0 is positive 3, because that will turn this binomial into 0. The 0 here is negative 3. The 0 here is positive 2. The 0 here is negative 2. Now notice all of these have multiplicity of 1. We don't always write that if it has multiplicity of 1. We can probably just list the roots. Okay, let's take a look at the fundamental theorem of algebra. This sounds really important, right? The fundamental theorem of algebra says that every polynomial function of degree n is greater than or equal to 1 has at least one zero. And the corollary says that every polynomial function of degree n greater than 1 has n zeros. So notice, if I have this polynomial, I know that it will have 4 roots or zeros, because that is a degree 4 polynomial. So I'm looking for 4 roots or 4 zeros. Now, notice I keep saying roots or zeros. They're very, very similar concepts. It's just one has to do with when you're factoring what makes it equal 0, and the other has to do with whether it's in function form. So when it's a function, we tend to say roots. When it's an equation that equals 0, we will say zeros. Now, they're basically the same thing, so I tend to use the words a little interchangeably, even though they have a slight difference. So let's just take a look at the fundamental theorem of algebra and an example of what you might be asked for this. Okay, it says to find the number of factors or roots of the polynomial, and we have p of x equals 3x to the 5th plus 18x to the fourth plus 27x cubed. Notice this is in standard form. The degree of this is 5. So there should be 5 factors, so 5 binomials multiplied together. Or we can say that there are 5 zeros of this, or 5 roots of this. Okay, the last thing I have for you in this video is just something that I want you to put in your notes. This is a factoring method that we can use if factoring by a GCF or factoring a trinomial or any of those special patterns don't work. And this actually works with, I'd say, 90% of polynomials. So if you don't like the factoring that I've shown you, try this factoring instead. Okay, so these are steps for factoring a polynomial, and this would be like if GCF didn't work, or if you can't factor a trinomial, or if there's not a difference of 2 cubes. So if it's not something familiar, but this will also work on almost any polynomial that can be factored. So step 1 is to find the number of roots using that Fundamental Theorem of Algebra. Step 2, use the rational root theorem to find all of the possible rational roots, and we'll talk about that in another day. You can graph the function on the calculator to find the roots that are probable. Use synthetic division to check the roots. When you get to a quadratic, you can use the quadratic formula, or you can continue factoring. And then finally, you write your answers as a list of zeros and a product of binomials. So make sure those steps are written down. We will go into them in more detail, either in a different video or in class.